Hello everyone. Today let us understand the application of photoisomerization in biological system. So mainly when we are talking about biological system, we can say about the process of vision. So mainly in the process of vision, photoisomerization helps. So we will understand that today. Vitamin A, which is a fat-soluble vitamin, comprises of retinol, and many other carotenoids. So here mainly we are learning how there is photoisomerization from cis retinal to trans retinal and how it helps in the process of vision. So now mainly we have the 11 cis retinal that you can see on the screen. It combines with opsin. Opsin now is a protein which mainly helps, that is mainly it is having photoreceptors, and it also helps in the process of vision. So now when 11 cis retinal, that is a structure with an aldehyde group, reacts with opsin, so you can see here there is an amine group linked to it. So mainly aldehyde, when they react with amine, they form with the dehydration, removal of water molecule. You can see how an imine group is formed. So now the imine group, okay, which is bonded with the retinal, is called as rhodopsin. So here you can see the imine group. So imine is formed when aldehyde reacts with an amine. So now this entire structure is the rhodopsin, mainly the retinal which reacts with opsin is called the rhodopsin. So again, rhodopsin is a red pigment and it is a photosensitive substance, again, which absorbs radiation and then it gives the vision. So now this rhodopsin absorbs suitable wavelength of light around 500 nanometers, and it gets dissociated into trans and opsin. So now here there is a very interesting factor that we have to understand. Opsin has a pocket. So now inside the opsin only the Z isomer fits, that is the cis isomer. But during the process of vision, as you see here, rhodopsin, when it takes in wavelength of around 500 nanometer, it is dissociated to trans and opsin. Now here there is a disturbance in the opsin, because now the pocket of opsin, which can only fit Z, but now there is the E isomer. So that is why again the trans retinal will undergo in the presence of enzyme, it gets reconverted to the cis isomer. So now here we have this is how the process of vision takes place. So mainly it is rhodopsin which takes in suitable wavelength of light and which helps in the okay, so rhodopsin is okay, so rhodopsin mainly takes suitable wavelength of light, and this is how the conversion of cis to trans isomer takes place. So now here you can have a look how this is happening. So now next let us see the mechanism of how imine changes to aldehyde and amine. So now here first is the red structure that you can see, that is nothing but the long chain retinal. Okay, now here we have to understand imine which is formed here. So there's an imine here, and in presence of water, that is oxygen being electronegative, bonds to the carbon of the imine. And here you can see how oxygen gets a three bonds around it and a positive charge. Now the positive charge on oxygen has to be removed. So that's when another water molecule takes up the, that is, there is a deprotonation happening, Okay, and the water molecule only takes up the proton, and here you can see how the lone pair, I mean how the negative charge on oxygen has been got. Okay, that's how the proton is deprotonated by water to form hydronium ion, and here you can see a negative charge on oxygen. Now next step, what happens is, since nitrogen has a lone pair because it's only bonded to three bonds, one with the carbon of the retinal, another one is with the hydrogen, and the other one is with the oxygen. So nitrogen takes up the proton and forms NH2 plus. So here you can see how the nitrogen forms NH2 plus. Now there is a negative charge on oxygen. Now this oxygen, mainly what happens is, there is going to be movement of electron of the bond towards. So here you can see how the negative charge goes towards the carbon to form a double bond, and there is a dissociation, complete transfer of electron towards nitrogen, and this is how you are getting an aldehyde and an amine. So this is how an imine in presence of water forms aldehyde and imine. Okay, so this is the mechanism. Thank you.